Here we're going to talk through the different ways the derivative can come up in applications, and then we'll look at a specific business application and an economics application. So, in general, with an application, if we're evaluating the derivative, then what we're really evaluating is a rate of change. Could be instantaneous rate of change that's for the derivative. So that's where we're really looking at a slope with some change in output over change in input. Depending on the word problem, if we're trying to evaluate the units on the derivative, then what you want to do is, like with our slope, we usually take the units of the numerator and then it's divided by the units of the denominator. But instead of division, we use the word per. So like miles per hour, dollars per minute. So what we do is you want to take the y units and then whatever those are per, and then whatever the x units are. And that's how you would describe it in words. If we're trying to evaluate something graphically, so let's say we have a graph that does this, and we want to find a derivative. What we would want to take is a coordinate on our function, and what we would want to do is try to draw the tangent line at that point. And what we would be interested in is the slope of that tangent line. So f prime of x, our derivative, is the slope of the line that is tangent to f of x at some coordinate x as the x coordinate, f of x as the y coordinate. All right. Let's talk about physical applications. So dealing with physics, and we touched on this at the end of that last video, talking about a position function, velocity function, and acceleration function. So we described this as s of t, which is giving a position, so some distance at a certain time. So let's give our units here. Let's say this is giving measurements in miles. So if we take the derivative of this function, so s prime of t, that's the same as mapping the velocity at a time. Velocity at a certain time, which we could describe that function as v of t. So units for this, let's say our units for time is hours. This would be miles per hour. And then this last one, if we take the derivative of that function, so if we talk about this second derivative of s of t, which would be the same thing as the first derivative of v of t, this would be mapping the acceleration at a time. And we call this function a of t. Now the units for this get kind of weird, but this would be miles per hour squared. So our unit of time would be squared there, or our denominator would be squared with how we were taking the derivative. Okay, and our last piece, which we're going to talk about at the bottom here with a business model. So we're going to talk about marginal cost, which I'll redefine down below there, but it's basically a concept we talked about in Math 147 that we're going to revisit here. We could talk about marginal revenue. We could talk about marginal profit. but it's this idea of marginal. So how is it changing in that instant? That is going to be this idea of a derivative, or that instantaneous rate of change. When we deal with these, the units for the derivative that we'll be using, so cost, revenue, and profit are all in terms of money, and then it's per, and then typically we're describing these in terms of the number of units that we've produced, or the number of items. So our units for the derivative will typically be $1 per item. And with that, let's go to our business application. We'll go ahead and do this all in one big video here. So, some terms that come from this section from Math 147, and we're just going to adjust our definition a little bit for marginal cost to relate the idea of a derivative. So, a fixed cost. This is some initial cost, or an upfront cost. Something that will be incurred just once, whether it's like buying equipment or paying rent. The idea is that this cost is regardless of the number of items that we're producing. It doesn't matter how many items we're producing, we're going to have this cost in here. The total variable cost, or TVC, is the money spent to produce Q items. So Q is the quantity. So the quantity of items. So with this, it does depend on how much money we're spending. This is typically in units of dollar per item. It's typically, if it's a linear function, that would be the idea of our slope. So it's how the cost is increasing per item. So this could be production costs or whatever manufacturing fees there are for a single item. Okay, so fixed cost and total variable cost make up this idea of total cost. So notice variable isn't in the wording here. So with this, we're just taking our fixed cost plus that total variable cost. So if we add those together, we'll get our total cost. The average cost is going to come from, if we take that total cost that we just found and divide it by the number of items that we produce. So this is going to find us the average cost per item. And now, all building up to marginal cost. So marginal cost, to revisit this definition from 147, is the idea of what is the cost of producing one extra item. So it's the cost of the next item. So marginal cost for some quantity of items is equal to taking the total cost of Q plus one item, so one additional item, minus the total cost of just Q items. So if you're at a certain level of production, what's the cost of having one extra item? Now this idea is getting close to this concept of instantaneous rate of change. It's like we want to look at this value Q and see how cost is changing in that very moment. And that's the idea of the derivative. So if we need to find a function or a value for this marginal cost, actually let me use a different color here because this is our new piece. The marginal cost of producing Q items would be the derivative of the total cost of producing those Q items. So this is going to evaluate how total cost is changing right at that value of Q. And that idea is the idea of marginal cost. Let's go ahead and look at an example here, and we'll even talk about, since this deals with the table, I'll kind of do a little side example of what if we were given a function. So we have this table here with Q items 0, 100, 200, or 300, and then the total cost 20,000, 35,000, 45,000, or 53,000. So we want to know what is the fixed cost. So the fixed cost will show up when Q is 0, because remember, it's regardless of how many items we produce, what's our cost, and that's coming through when Q is 0, total cost is 20,000. So our fixed cost is $20,000. So no matter what, we're going to have a cost of 20,000. When 200 items are made, what is the total variable cost? So when we're at 200, which is right here with that total cost of 45,000, so our total variable cost is going to come from, well, we can use our formula up here. Let's use that formula where total cost is equal to fixed cost plus total variable cost. Well, for 200 items, that total cost is 45,000. Fixed cost we just found is always 20,000, and then plus our unknown of total variable cost. So to solve for total variable cost, we're just going to take that 45,000 minus 20,000, which is going to be $25,000. So our total variable cost is 25,000. The average variable cost. So the average variable cost, notice this is a little different. This is going to take our total variable cost divided by the number of items. So up here, it was just the average cost. So we just took the average of this. Since we want the average variable cost, we want to use that value. So we're going to take that 25,000 and divide by 200, which is $125. So on average, there's a variable cost of $125 per item. Okay, when 200 items are made, estimate the marginal cost. And here we're going to have some difficulty because we can't see what 201 is. So what we need to do is, or at least the best we can do, is evaluate the kind of change in cost around 200. So we'll look to the left of it and we'll look to the right of it. So the change in quantity when we move from 100 to 200 is adding on 100. The change in total cost between 100 items and 200 items is that difference between 35,000 and 45,000, which is a positive 10,000. So what we get is this one kind of change in total cost coming from that 10,000. Sorry, it wouldn't really be change in total cost, but let's just describe it as slope out of ease. So 10,000 for that change in total cost over the number of items change, which is 100. So for that, I don't even really want to call it marginal cost because it is a difference of 100 items, but we have this change of positive 100. Now let's see what happens on the other side of 200. So going from 200 to 300, change in Q is still positive 100. We're going from 45,000 to 53,000. So our change in total cost is coming in at $8,000. So with that one, we're getting a slope of 8,000 over 100, which will be a slope of 80. So to get marginal cost, which is all about this instantaneous rate of change at 200, the best we can do is look at these slopes around it. And what we're just going to do is average them. So we're going to take 100 plus 80 over 2. And the best we can do is this $90 estimated marginal cost. So it's not great, but that's the best we can do. Now, you'll notice with this that the derivative, like the idea of the derivative was there, but we couldn't actually do it, and that's because we had a table. If we had some function, so like just for simplicity, let's say total cost of Q was equal to Q squared. That's not at all what this function is, but let's say that was the case. And we're just going to skip down to marginal cost. So if we wanted to do this marginal cost calculation, then what we would start doing is if we wanted to find this marginal cost of 200, we would evaluate the derivative of that total cost function at 200, which means we would look at this limit as h approaches 0, total cost of 200 plus h minus total cost of 200 over h. And we would go through all those steps of simplifying that we looked at in previous videos. But this video is getting quite long, so I'm going to end it there. But if we had the function, that's how we could get an exact marginal cost, is by using our derivative formula to calculate.